Alrighty, here we go. The fun stuff. Algebraic limits. So we'll be doing algebra today. And in this particular note, although not in all of mathematics, there are 1, 2, 3, 4 common problems in limits that require you to do some heavy duty, in some cases, algebra. This is not the extent of limits, so don't think that for a second. And everything we do in the 2 lessons after this will depend on one of these types of algebraic problem solving. And it's not really problem solving, but it's figuring out which one of these applies to the question. So hopefully in the course of this note, I will be able to explain to you how to tell one from the other. I think it's pretty obvious, but I'd like to state it out loud. So the first part about this stuff right here, was written in the graphical limits lesson. A limit is a boundary that may not be passed. It's the exact value. The limiting value of a function is the numerical value that the function will have if the limit is reached. So what happens in these questions is I give you an f at x, or in this case an f at h, and I ask you to substitute this number in for the h. And there are some problems, as in sometimes you can't sub the number in because of bad math. So if that's the case, then you have to fix it. But sometimes there's trick questions. Sometimes I just give you a question where there's no problem with you substituting this in. And these are the hardest questions because you're expecting heavy-duty math and nothing happens. So with this one, and I'll do this in black, you have limit as h approaches 0 of h plus 4, maybe in brackets, maybe not, depending on the teacher and the textbook. This says plug the 0 in. So as soon as you are allowed to plug the 0 in, this instruction disappears. So I can sub the 0 in without any bad math whatsoever. And I get myself an answer. And those are the hardest questions, because as I said, you're expecting so much more. So let's look at a air quotes problem. So I don't know how long these are going to take, as in how much space. So I am going to carve off a new page for type 2. And I'll take this stuff over and we'll worry about the other questions in a sec. So this is where I get to say to you, yeah, there's factoring in every unit of this course. So in this particular question, I've given you an f at x, and I'm asking you to plug 0 in for all the x's. Now, you can totally sub 0 into the numerator. And I say that because 2 times 0 squared plus 5 times 0 is 0. And 0 in numerators are just fine. However, if I ask you to sub a 0 into the denominator, you will create a 0 on the bottom. And that's totally math illegal. This is known, so somebody gave it a name, as an indeterminate form, meaning you can't determine it. So what you have to do is you have to fix the problem. Now, there are going to be questions in your life, if you go on in math, that say find the limit if possible. I won't give you those in this course. You're just warming up to the idea that these things exist. So the thing I notice about this numerator is that we can take out an x. And in this case, nothing else. And if we take out an x, what that lets us do, legally, is to cancel those, leaving a 1 behind and ending up with 2x plus 5. Now, if you write it like this, I have to take off some notation marks because you've lost the instruction. So the entire length of the question, you have to write x approaches 0, limit as x approaches 0, limit as x approaches 0. And then the second that you are math legally allowed to put in the 0, you can lose the instruction. And 2 times 0 is 0. Remember those 0 times tables. and we get an answer of 5. Now, I will come back to this question, and I will tell you how this applies to what we did graphically. But before we do that, let's try a couple more questions that have to do with factoring. So, same thing. And I hope you look at this and say, okay, there's number 1, I can't sub this in, so it's not a no problem question. Number 2, the only thing I can possibly think of doing here is factoring. So before I forget, I write this down, and then I factor the numerator because it can be factored. So 2 numbers that multiply to be 2, 2 numbers that multiply to be 5, complex trinomial factoring. And it is not a surprise. These questions are sort of pre-planned for you. It is not a surprise that we end up with a factor of x minus 1, because the whole point is to eliminate the problem. So now that we've eliminated it, and no, you don't always end up with 2x plus 5. That would just be silly. It's just these first 2 examples. Now that we've ended up with that, I can put the 1 in without creating any bad math, show as much or as little work as you feel like, and then boom, you're done. So this is the y value for the x value. And again, I will come back to this question and show you a picture representation that hopefully you can understand for all of them. So, next question. This one's a bit of a trickster because we haven't done this since the beginning repeatedly. But I can't take this -2 and plug it into the denominator because -2 plus 2 is 0. 0 in the denominator is bad math. Indeterminate form. So, I'm going to write down x plus 2 again. And then I hope you notice that this numerator is a sum of cubes. So we lay down our binomial size bracket and our trinomial size bracket. See how math is pretty cyclical, as in it's coming back. Everything we did before comes back. So the cube root of x cubed is x, and then square it in position 1 back here. The cube root of 8 is 2, and then square it in its position back there, and then multiply those 2 together in the center. Then go back to the original question, which is a sum. So you keep it as a sum, you change it, and it's always plus. And again, not surprisingly, because the questions are all set up, we end up having to do this. Now sometimes you have to factor both the numerator and the denominator, and what'll happen is you'll cross out part of it, and you will have to sub into a new factored form, numerator and denominator, and possibly end up as a fraction. So a reminder, the second you are allowed to put this number in and not create bad math, the instruction disappears, and then you can do your bad maths. So -2 squared is 4, -2 times -2 is +4, plus the 4 at the back ends up giving us an answer of 12. So I'm going to leave this here, but I'm going to set up Desmos so that you can see what fits in visually before we start something that is pretty high-tech mathematically. So I'm going to take a little break. So I typed this into Desmos so that you could see the graph of y equals 2x squared plus 5x all over x. Now, a reminder that this is a rational function. So this could have vertical, horizontal, oblique asymptotes. It could have holes. And the idea that you've been able to factor and eliminate something does lend itself very nicely to holes. So here is the picture, which is a straight line. And maybe you weren't expecting that because maybe you thought, oh, rational functions shouldn't be straight lines, but it's not really a straight line, because if I hover my cursor over the answer to this question, the y value of 5, I actually get a hole. So when I cut and paste this picture onto your little note, I can't leave it as it is. I'm going to have to, first of all, scale it back so it's not covering everything. And second of all, I have to dig out my red pen just for, oh my gosh, I can't find my pen at all. I have to find my red pen just for color coordination. And at 5, I have to put a hole. So hopefully you can see in this case that if you're coming in from the left to x equals 0, you're getting to a value of 5. And if you're coming in from the right, you're getting to a value of 5. So this picture is exactly what we were doing, because you end up with a 5. So this shouldn't surprise you that graphical limits and algebraic limits kind of collide in a picture, because everything in this course collides in a picture. All right. If I did that for this one, which I will not, you would end up with a hole because you've crossed out this. Same with this question, only you wouldn't end up with a line, you'd end up with a parabola. So onwards and upwards. This one, you don't want me to draw you the picture either. So the first thing you want to do is you want to say, I've got some roots. These roots make this question look a lot different than this. But before you start panicking and starting to do high-level math, you want to try to see if this number can be subbed in for x, and it cannot. So that means that you have a problem. The roots, 1 or 2 of them, could happen in the numerator or they could happen in the denominator, but you go through the same steps. And the step is that you have to multiply by 1. Which does nothing. But you don't actually multiply by the number 1, because that wouldn't really help you all that much. You want to multiply by a special 1, and the 1 is whatever the root line is. So this is radicals. So you want to take the whole level, so in this case the numerator, you want to multiply by the exact same roots, so keep your contents the same, but have a plus sign instead. So that sets you up for a difference of squares looking thing, and because it's the same on the top and the bottom, you are just multiplying by 1. Now, just so you know, these two things right here, where can I write this? These two things right here, the contents of this and the contents of this, those things, way back in difference of squares, were called conjugates. They're still called conjugates now, only they're super fancy. So what you want to do is you want to multiply by a 1, you want to multiply by the opposite sign so that you create a difference of squares. You want to make sure that you copy the exact same thing on the top and the bottom, and then you want to FOIL. Actually, you probably don't want to FOIL, but you do have to FOIL. So I'm going to go through all of that here, and I hope I can squash it in, but it's probably going to take me a very long line. Now the deal is you want to FOIL only where the conjugates are. So you are allowed to be half lazy. You are allowed to take the denominator, in this case, bracket the big stuff, because this is an entire quantity, and multiply it, and say you're going to multiply it by that. Because ideally, somewhere along the line, you want to cross out an x on the top and an x on the bottom. So if you multiply that in, you're going to get rid of the ability to see that you can take this out. So now is the hard part, kind of, sort of. I don't find this difficult. I may sneeze here. Oh my gosh. I think I'm going to sneeze. Hold on. Oh, I didn't catch it in time. Sorry. Excuse me. Oh. Well, that livened up this episode of math. All right. So the first thing is you have to multiply these two things together. And I'm sorry about all the colors. So we have root x plus 2 times root x plus 2. And that means we have actually root, oh, didn't mean to do that in red. We have root x plus 2 squared. The next thing we have, the O, root x plus 2 times positive root 2. So what you can do there is you can just smush them together. Don't make any typos though. So that's F and O out of FOIL, and here's inside, so I, and we have negative root 2 times this root, which is just a smush job, and then finally negative root 2 times positive root 2 is negative root 2 squared, or root 4. And you can write down your preference. Now, this is actually quite pretty when you get down to it, and maybe you don't realize it yet. So I'm just rewriting the denominator, which I find super annoying. Okay, you can't like use ditto marks or anything. This isn't a place that you can do it. This is a formal solution. So the reason I say this is pretty is because this piece of information and this piece of information are identical, and one of them's positive and one of them's negative. And that means there's 0 of them, and that should always happen because you were smart enough to pick the conjugate. Now, that's 2 out of 4 of these pieces. That's the OI part of FOIL, and that should happen every single time. But anytime you have a root and an exponent 2, that means they cancel each other out, and we're left with x plus 2. Now, you do not need the brackets in this case because there's nothing out front, but sometimes you do, which is why I'm putting them there. Like I said, those cancel out, and every single time this should be perfectly square rootable. 4 is a perfect square. 4, 9, 16, 25, etc. So we have subtract 2. Now the reason that's so good is because this is a positive 2 and this is a negative 2, which means we end up with 0 numbers. Which means there's an x in the numerator, not surprisingly, that will cancel with the x in the denominator. So like I said, these questions are sort of pre-planned. And now I can do that. And then I'm going to have a line of neatness. And it's because I see a lot of things go wrong. Actually, one thing in particular go wrong with this question, and that is that people, as in you, will just randomly take this denominator and leave it there because they think they've crossed everything out. But a denominator has to stay a denominator the whole time. So you need something in the numerator to kind of hold it down. And there's nothing up there except when you cross these things out, you actually leave a 1 behind. So you need that there. Now I can put in the 0. See, at the very beginning, we could not put in the 0. We had to do all this crazy math, the math you're expecting for that first one. So now we can actually sub it in. I'm going to show all my work. So that's root 2 plus root 2, which is not root 4. It's actually 1 root 2 plus a second root 2 is 2 root 2, and that is a denominator. So there is your answer. So your answers don't always end up pretty. So I need a sec for a hand cramp, unless I can't figure out how to pause this. All right, so I hope you notice a couple of things about this question. I also hope you notice a couple of things about this question, or at least the fact that there exists a root, and when you have roots, it indicates you either have the no problem question, and it's like a trick question because you're expecting way more math, you're expecting this stuff, or it's a conjugate question. So this is called the conjugate method. I hope you notice a couple of things that are different here. Number one, there are x's and h's. I am giving you a value that is an h value, and because it's an h value, we should expect x's to be left over, as opposed to all the other questions where it was only x's and I gave you an x value, so no surprise that you end up with no x's and just numbers. So back to this one. You might have a common denominator question when you have a triple or 4-level fraction, but you always want to test this number in the question to make sure that it can't be done. Because if you can sub that number in, I don't want you to go through all the trouble of getting a common denominator when it's just simply a BEDMAS question. So here, if I sub 0 in for h, I do in fact end up with a 0 in the denominator. That's bad math, so we have to do some other math. So I'm going to color coordinate this. So I'm going to get you to focus on this part right here, and I'm going to deal with it in blue. I have to eventually remember to write this down and this, but right now let's just focus on this part. And that is two fractions, added or subtracted, which means I have to do a common denominator. Now, if you're a wizard at getting a common denominator without this, that's fine. Just make sure you do it properly. I am going to do the 1, 2, 3 thing. So the first thing is that. The first thing is multiplying those two pieces of information together. So that looks like x times x plus h. Again, don't multiply that in unless you have proven that you need to yet. You can always go back and do it later. Number 2, this direction must be done before the other one. So that's 2 times x, which is 2x. Then you lay down your subtraction sign because it was a subtraction sign. And you do the third thing out of the 1, 2, 3 thing that gets you a common denominator, and that is, and I'm going to take my time with this, 2 times x plus h. Now some of you are going to race ahead and want to multiply the 2 through. Be very careful, please. That's where mistakes happen in addition to getting common denominators. Now, like I said, I have to remember this stuff out front with the equal sign on the edge. If I go back through all the questions, equal sign was on the very, very left. When I got more difficult, the equal sign was on the very, very left, then the limit instruction until we didn't need it. Here it is again. So the equal sign is, like normal, always on the left. A lot of people like to dump it in here. That's not where it belongs. So I've got my equal sign on the left. I've got my instruction because I haven't used the number yet. I've got my common denominator almost figured out. Don't lose this. And I don't like 3-level fractions, so I'm going to put it there with old school division. So I'm still going to focus your attention on the blue bracket. If I take this blue bracket and multiply out the numerator, I get 2x minus 2x minus 2h. That is a mistake that happens quite frequently, is you don't carry the subtraction through when it's subtraction. So you don't have to worry about it when it's addition. And although it cramps my hand and annoys me, I still have to write this stuff down. So my two x's will cancel each other out, and I'll end up with negative 2h in the numerator and x times x plus h in the denominator. I still have my instruction out front. And then finally, I have divided by h. But I want to do two things at once. So up here, at any point, you can imagine or lay down a little over 1. I am going to put a dot instead of a times because some people's timeses look like x's. And then we have that. And you see why this is so useful. Bam, bam. Get them out of there. It's all multiplying, so you can't cross out this one. You have to cross out the one that's all by itself or one that's only being multiplied and not added and subtracted. So annoyingly enough, I'm going to have a line of neatness. Some of you will not need it because you are neater than me. I need it because this is going online. I'm going to be an internet sensation. And then I can put this 0 in. But I can only put the 0 in for the h. So negative 2, instruction disappears, x times x plus 0, negative 2 over x times x, which is x squared. So when we go on to do the next two, the last two lessons for limits, I need you to realize that one of these methods is going to come into play. It is likely not this one because the questions are normally larger, but I hope that you can look at the questions and say, oh, I see a fraction. It's the common denominator type. I'm being very popular even at 8:41 in the morning. I hope that if you see roots, you think conjugate method. And I hope that if you don't see roots and you don't see fractions, as in triple layer or more fractions, you'll think about doing the factoring method. So I'm going to leave you with that right now, and I'll get you to check the Google Classroom for any of the suggested questions if you are in my class. Anyways, that is all. I have no idea how long this is, but I think I set new records again.